We'll do this. Let's do. How is everybody doing back? Good? Glad to be back. I'm just going to give you the table, then I'm just going to give you the one sheet. Since you have the rest of it at home, make sure you bring that tomorrow, okay? All right. Hopefully everybody at home's doing well too. Let's get into this, shall we? Hopefully everybody's feeling good. Hopefully my mic is working at home. Cool. Okay. And let's see if everybody's here. So everybody's got Bishop. All right. Does anybody have any questions for me? I want you to take a look at the week schedule. I guess while I'm doing this, you can take a look. We will have a test on, you do not have school on Friday. Don't let me say Friday. We will have a test on Thursday. It will be the unit test over everything. Okay. It will be all the way since the beginning of Unit 2. And you have a whole big packet that has everything in Unit 2 in it. Okay, so hopefully that's all filled out. And the review sheet is already in that packet if you want to start to look at it, because we are a little squunched this week because we don't have school on Friday. We have notes on separation of mixtures today. Tomorrow we'll talk about the law of conservation of mass. And then on Wednesday, we're going to do a review map. We'll do a concept map to make sure everybody understands everything. I'll tell you exactly what's on the test, how to go over for everything. And then you'll have a big test for Unit 2 on Thursday. No school on Friday. And then we get into what's called thermochemistry. Thermochemistry is the hardest unit in the first semester. Stoichiometry is the hardest unit in the second semester. So we're coming up to some hard math and things like that in the next unit. So you want to make sure we are geared up, ready to go for that. But first, we got to get through the test on Thursday. I know that Thursday is the first day of quarter 2, but nobody likes to start off a quarter with a test. So we will actually put this test, we will put it on the first quarter. Okay. So make sure if you want your grade to come up, this is a perfect opportunity to bring your grade up. Okay. Because it will be worth quite a few points. Perfect. All right. So with that said, let's talk about 4 different techniques to separate mixtures, and then we'll get you into some practice because they'll probably have a separation question on the test. So mixtures. For instance, I have beads in water up here. This is a mixture. They are not physically joined together. They're not chemically joined together, so they can be separated by physical means. So go ahead, and I would circle this last part here. You might see that in your lecture questions. So they are not chemically joined. They are just together physically. So you can separate them by physical means. If I wanted to get these beads out of this water, what's something I could do? Okay, dump them out, pick them out, things like that. What you would probably maybe, if you had all your chemistry tools together, you'd say, here's a funnel and a filter, and I just pour them through, and then what gets stopped? The bead gets stopped, and the liquid goes through. So we got to talk about how we can physically do things, okay, in order to separate our mixtures. So that's the idea today, okay? Oh, are you okay? I'm sorry there, sir. I didn't know if you needed something from me. I found one of these on the floor, so as I'm throwing things to you. There you go. There you go. All right. So what you want to do when you're given a mixture, like on today's practice worksheet, they're going to say, here's a mixture. What you want to do is you want to look at their properties. Is something soluble? Is something insoluble? What's the density? What's the melting point? What's the boiling point? Okay. So you always look at the properties. For instance, you might look at boiling point. You might look at density. You might look at solubility. And once you see differences in your mixture, then you can separate them. Okay. Awesome. So the only problem is if you have some very similar properties, like if you have one with a boiling point at 200 and one at a boiling point at 212, like that's not those are very, very close. So you want things with very different properties. So make sure you take a look at all the properties. So I have some total cereal up here. Who has cereal for breakfast? Anybody cereal person? Cereal? That's right. What kind of cereal did you have this morning?
I had some Fruity Pebbles and some Reese's
Oh, so you like the cereal, like both of them. Fantastic. Okay. You didn't have Total?
No,
Why not?
we had Captain.
Oh, see. So Total is more on the like tastes like cardboard side. And the reason why it's called Total is because it has your total amount of everything that you need in it is what they say. So along with milk, if you do that, you have like 100% of your vitamin A, vitamin C, calcium, iron, vitamin E, D, thiamine, riboflavin, whole bunch of stuff. But what I'm interested in is this is a mixture with a whole bunch of stuff. Cereal is a mixture. Okay. I'm interested in the iron. Okay. There is elemental pure iron in here, and you actually need to eat it in order to make the hemoglobin work in your blood. So I'm going to take some cereal here. Wonderful. And I'm going to put water on it. That's like sacrilege, I know, for cereal because you're putting milk in there, right? And what that's going to do is that's just going to start to soften it up so we can get the actual iron out of it. Okay. So what are we pulling out of the cereal? We're pulling out iron. What you have to do is you have to look at some properties. Okay. And iron happens to be what? Your refrigerator is made of iron. And what will stick to it? That didn't work very well. Okay. But a magnet, right? Magnets. So what we're going to do is we're actually going to use a magnet to pull the iron out of this cereal. So what we have, this is called a stirring bar. They look a little like this. Okay, it's nice and clean. And this is called a hot plate stirring plate. And what this magnet does is it is magnetized onto there, and then it spins. Okay, so this is one way that we can stir solutions when we don't want to have to like stir it for 5 hours, get things to dissolve. So that's a little magnet. And it's going to stir my solution. So what I'm going to do is I'm going to take this magnet. It's clean. It's got nothing on it. Drop it in there. And I'm just going to let it stir around. Gotta give it a minute to get started here. And throughout the period, I'm just going to let it stir and see if it can't get some of that iron to pull out of this cereal. Okay, just like if you were to put a magnet on your refrigerator, the magnet in here should be able to pull out the iron in the cereal. Okay, that makes sense. Good. So we're gonna let that do its thing. The thing about separation techniques is sometimes they take a while to work. All right, so that's the first thing we're gonna talk about there. Then the first separation technique that you need to know about is called distillation. Distillation, you might have heard before because some foods use it, things like that. Distillation is when you separate based by boiling point. Distillation is separation based on boiling point. That's how you can get distilled water. Okay, if you need to separate certain liquids that are soluble in each other, you will heat the mixture until the substance with the lowest boiling point evaporates away. You heat the mixture until the lowest boiling point evaporates away. So how we're going to do this is we're going to come on over here. People at home, hopefully don't get motion sick. We have a distillation apparatus set up over here. Okay. And I'm going to try to talk really loud because my microphone doesn't reach. All right. So if you would turn your attention over here, what we are going to do is we are going to distill some peach pop. What is in peach pop, do you think? It's a mixture. It has a whole bunch of stuff in it. What's one thing?
Sugar.
Sugar. Water, carbon dioxide, absolutely. Do you think this is the color of real peaches? They just squeezed a peach in there, and that's the color that came out. There's probably flavoring, food coloring, a whole bunch of different stuff in this mixture, okay? And it's all soluble. Would you call this a homogeneous or a heterogeneous mixture here? This is a homogeneous mixture. Okay, got me? So there we go. So what I did is I poured a little bit of pop into this round bottom flask. What I'm going to do is I'm going to heat this. So I'm going to turn on my Bunsen burner here. And now we are going to boil this peach pop. When the thing with the lowest boiling point boils away, where is it going to go up? Okay. And what we're going to do is instead of allowing it to leave, we put a stopper on it, and that's going to force whatever vapors come out to be pushed down the tube. And what I'm going to do is I'm going to turn on a little cool water here. And now I'm cooling down. There's a little insert here in this tube. And so anything that boils away is then going to be recondensed, and we should be able to catch it in the beaker at the bottom. So we are separating based on boiling point, okay? So we're going to figure out which has the lowest boiling point, the water, the flavoring, the color, the sugar. So in your mind, I want you to think about what you think is going to come out the other end, okay? If we are going to boil it away, if you could capture whatever you boil away, what do you think will come out, okay? So that takes a minute. It also works faster when we kind of keep the heat in. So I'm just going to take a piece of aluminum foil, and I'm just going to give it a little coat so it stays warm. Oh, that's cute. Okay. So we're going to let that heat, and we are boiling, okay, the peach pop, and we're going to see what will distill away. Okay. All right. Back up to the front here. Most of these separation techniques take a little bit of time. That's why we got to kind of do it all. The next one is called filtration. So we're going to come back to this in a second. We'll figure that out. Filtration. Filtration separates mixtures by properties of solubility. Remember, let's remember, what does solubility mean? If it's soluble, it means it can do what? Dissolve. Okay. Solubility is when something can dissolve. So let's go back to my beads. Are my beads soluble? Are they dissolving in the water? No. Okay. Beads are not soluble. Is salt or sugar soluble? Yes. Okay. Can dissolve, cannot dissolve. When you are filtering, the only thing that you can filter out are the insoluble pieces. Okay. When you are filtering, this is very hard because sometimes people say, oh, I can just filter everything. That's no problem. But you have to remember, the only thing that's going to get stopped by the filter are things that are not dissolved. Okay. So let me do it. You're like, beads, that doesn't look like chemistry, because it's not. Let me make you guys a precipitate here. Beautiful. So I have some, is this magnesium sulfate? I have some magnesium sulfate, which is a clear liquid. Okay. You'll see it's a nice clear liquid there too. And then I'm going to mix it with another clear liquid. This is sodium hydroxide. And I'll come around here so you guys can see, and those of you at home. When I take these two clear liquids and I mix them together, I make a precipitate. If you'll see, now it's a cloudy white, okay, solution. And remember, last week in our notes, we said a precipitate is an insoluble solid that comes out of solution. So now you're like, hold on, how can I get that precipitate out? What I'm going to do is I'm going to take a piece of filter paper, because if I just poured it through here, this is a little too big to kind of filter anything. Filter paper, if you think about it like a coffee, kind of a coffee paper, it will let water and anything soluble go through, okay, but it will stop insoluble substances like your coffee grounds. So I'm going to fold this up, put this filter paper in here, and what's going to be caught when I'm filtering, what you're going to catch in the filter paper is, oh, sorry, that was the beads, or the precipitate is what is caught, and what goes through is the water. So you have to know that the insoluble things are the things that are stopped when you filter. So now I have a thinker question. Can I filter food coloring out of water and food coloring? I put 3 drops of blue or green food coloring in here. If I run this through a filter, will it take the green color out? Yes or no? Yes. No. Yes. No. I don't know. Maybe so. I don't know. Why would you think that it would or would not? I want you to think in your head. We'll do it right now. We'll prove it. We'll see what happens. Those of you at home, think about if I filter, okay? And think about it Filtration only stops insoluble substances. Are you ready? All right. Do you have your guess in your head about whether or not what's going to come through is going to be clear or green? Got some stuff going on over there? All right, ready? Here we go. Filter, filter, filter. Let me get a blue piece of paper in the back, or a clear. What's happening? It's not filtering it. Is the green coming through in the bottom too? Why? Because the green food coloring is what? It's soluble, right? So if I have salt water, if I have salt water, can I just filter it and get the salt out? No, the salt will go through. Sugar water, can I just filter it? The sugar will come right out? No. That's one of the main problems why we have a hard time with all this seawater. We can't just like filter the salt out of the seawater, okay? So was caught in the filter paper? Nothing. The food coloring and the water went through because food coloring is soluble, soluble, soluble. So if it is dissolved, it goes right through. Does that make sense? The only real way that you can kind of separate something that's dissolved is you got to distill it. Okay, you got to boil away the water and you can get whatever you want behind. If I take this and I boil away the water, I will be left behind with my food coloring. Okay, it's one of the only ways to get that to go separate. All right, but that was a good question. Good thinking about that. I like it. I like the thinking. Okay, perfect. So those are the first two ways that we can separate mixtures. All right, we got two more. Oh, we'll come back to that. We'll take a look at that guy in a minute here. All right, the next one's called the centrifuge. And the centrifuge is probably something you've seen on like maybe in like a chemistry in science on TV or maybe in a movie. If you watch like some of those shows where they're doing like DNA, forensics and stuff like that. A centrifuge separates mixtures based on density and solubility. Okay? It only works on insoluble things as well. Okay? If things are not dissolved, then again, it will work. Only works to collect insoluble, less dense things. Have you guys ever been to the carnival and you go into that ride where you stand in it and it spins so fast you like stick to the walls? You know what I'm saying? Okay, perfect. And then you get sick because you think you can do it again and then you can't, or maybe I'm just old. I don't know. But so what you're going to see is if you have a mixture and it spins super fast, anything that is insoluble will, and less dense will float to the top and more dense will float to the bottom. So when it spins, the insoluble items that are more dense settle out to the bottom. And then the things that are less dense will go to the top, because you guys should know that from our density unit, less dense things float. Okay. So the centrifuge is always, if and when we get to do a lab, the centrifuge will always be in the fume hood, kind of where it kind of, just in case there's an issue, it's already in there. And what the centrifuge does is there are tubes that are called centrifuge tubes. They're not test tubes, and they fit right inside of these nice little slots right here. And then this thing will spin. And when it spins, the more heavy things go to the bottom that are insoluble, and the less dense things that are insoluble go to the top. So what I have here is I'm going to take this precipitate. Okay, remember this is a solid in solution. And I'm going to, oh no, people at home, I forgot to tell you. Centrifuge, stay with me, okay? Everybody can see this is completely white from the top to the bottom. That means my precipitate is in there, but remember, precipitates are insoluble. So what I'm going to do is I'm going to take this precipitate, which is solids inside my solution, I'm going to spin it, and the more dense solids should go to the bottom, and the less dense liquid should go to the top. Just because it's always fun. Remember, this only separates insoluble things. So I'm also going to take this and spin it and see if I can't spin the food coloring out of the water. You lock it, you turn it on, and now what it's going to do is it's going to spin really, really, really fast at a high RPM. And just like when you guys are in that carnival ride, the things that are more dense are going to be spun to the bottom, and the things that are less dense are going to spin and rise to the top. Okay? You'll see this in some DNA stuff. In some forensics labs, they have a lot of centrifuging and things like that to separate mixtures. Okay? All right. Should be good. Sounds like an old school microwave. Now, when you are physically using these in lab, you want to be very careful to wait until it's done spinning, because if you like try to stick your finger in there and then it gets stuck and then it rips off and then just blood, it's just gross. But so, okay. Never had that happen. Never had that. So it's still spinning, 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 spinning. And as you guys can see, and I probably could use another second. Oh my gosh, seriously. Separation techniques take a minute sometimes. How's every day? Good. Wonderful. Spinning, happening. What's happening over there? What color is the liquid coming out over my distillation tube? Is the food coloring coming out on the other end or no? Interesting. So we're leaving the orange in there. Interesting. All right. Beautiful. All right, that should have done it now. All right, so just like my beads in the water, beautiful, much better, okay? You can now see my white solid precipitate is at the bottom, and the leftover solution is now on the top, okay? So my solid is on the bottom, and then the extra solution's on the top. Then what you can do is you can just say, hey, I just want that white precipitate, pour the top off. Now I just have the white solid left behind. So do you think that the food coloring centrifuged out of the water? Because it's soluble. You could spin it all day and the food coloring will never come out, okay? Because this is soluble and you may only do, soluble things, okay? So let's talk about the demo here. So my mixture before was a white precipitate, and the way you write precipitate is PPT if you want. So the whole thing was white and the whole thing was green. All right. Then, after we centrifuged it with my precipitate, okay, the white precipitate was just at the bottom, correct? The white solid precipitate was at the bottom, and the top was clear. Okay, because this is more dense and this is less dense. However, did I get anything different out of my food coloring? Nope, the whole thing was still green. And the reason why is because this only works, like you guys said, on insoluble substances. Precipitate was not dissolved, so it can be separated. The food coloring dissolved, so it cannot be separated. Okay. Precipitate was insoluble, so we could separate it out. Wonderful. All right, we got one more separation technique. And you guys might have done this. I think some middle schools do chromatography in some of their stuff. We'll have to see. Wonderful. All right, chromatography separates based on color. Okay. Let me know if I'm going too fast. Just have these cut down periods here. We got time. Okay. Chromatography separates based on color. And so what I have are some markers here. And you know, like green is a mixture of yellow and blue, and purple is a mixture of red. And so what we're going to do is we're actually just going to, and there's a lab that we used to do that has a whole bunch of fun stuff in it, where you would actually make some art with this. So what you see, what happens is it's kind of like a coffee filter. The water goes up through the colors here, and it will take and separate out any colors within the dye that you will see. Okay, so chromatography is based on color. Awesome. So we got some thinking questions. We kind of talked about it here in a minute ago, but I would like for you guys to try to write your answer before we kind of go over it together. And just, you don't have to do the why part. We'll do that together to make sure you're right or wrong. Can I filter salt in salt water? Right, yes or no? Can I centrifuge out the salt in salt water? And then we'll answer the bottom one. So I want you to answer these two while we take a look over here at our distillation apparatus and talk about what we got going. All right. All right, so this is what came out of the distillation apparatus. Is this that same peach color? No. So what must be the boiling point of the coloring? Do you think it should be higher or lower than water? If the color's left in there, and this came out here, this has to have a higher, okay, and so we kind of said, this must have a higher boiling point than the water. Now, so does anybody think that this is just water? Looks like it, right? Okay, I would like for you to smell this. Okay, give this a smell. Is that just water? What does it have a smell to it? What does it smell like? Peaches? So it's a sweet smell, right? So the interesting thing is, obviously the sugar didn't come out. The sugar is a solid, it's a very high boiling point. But I usually pass this around. We can't do that right now. But this has a sweet smell because actually the flavoring came through with the water. Okay, so in there is probably leftover sugar, coloring, all that kind of stuff. But the flavoring has a very low boiling point as well. So that was on the very front here. We said we would go back to that.
So like it tastes like peaches, but it's healthy though.
Yeah, yes, but it doesn't have the sugar in it, so it might give you like a really like odd taste. You know what I'm saying? I've never tasted it because you're not supposed to eat out of glassware. But so what must have had the lowest boiling point was the flavoring in the water. Okay, but yes, so you would have the flavor portion without the sugar, and I'm sure that they count on those two things to kind of work together. Okay, perfect. Perfect. All right, back up to the front. Hopefully we're good here. All right. So let's go back to our thinker questions that we said we were going to do here. Oh, and then I got to show you my iron. Can I filter the salt out of salt water? No. Okay, why? Because that salt is dissolved or soluble. Could I centrifuge it? No. Again, because the salt is dissolved. So chromatography wouldn't help me at all because there's no different colors. So what is the only separation technique left if you had something dissolved in water, like salt water? How do you get the water away from the salt? The only thing you can do is boil it, which we call distillation. Perfect. Very good. Okay. Whoop, distillation. Boil away the water and leave behind the salt. So you will have a question on separation techniques on your test on Thursday, where I might give you a mixture, and then you would have to tell me, first I would boil away this, or first I would filter that, or you'll have to go through the steps. Okay? Does that make sense? So what I want you to do, find that little secondary piece of paper that we had, and it says separation techniques on it. That'll work. Beautiful. It's the second page in the little section, like the little half she gave. Perfect. The separation. Let me see if I wrote. Oops, have all the answers up here. So let me do this for a second. Wonderful, wonderful. And I want you to get your Chromebooks open if you do not mind. Chromebooks open and get this out. Chromebooks open, get this out. All right, let's do this. So we will start tomorrow by going over some of these, but what you will do is you'll use these 4 terms, fill them in down here. Okay, as you can see, my chromatography is working. The green that was the second one from the side over here is now yellow and blue. That's separate. When this red keeps going, it's going to pull more of the orange out of it. Here's my regular blue. It has dark blue and light blue in it, so that's chromatography. Then I want you to circle the bottom. There are some separation of mixture practices, things like this. And I also want you to do your lecture questions. So go into week 8 on your Chromebook. Go into week 8. Week 8. The Monday folder. Week 8. The Monday folder. Okay. And what you're going to do for the last few minutes here is you're going to do the 3 lecture questions in the Monday folder. And then you're also going to work on this worksheet. Okay. And the key is in the Monday folder as well if you would like to check yourself. Okay. Let's see if we can't figure out here what we got going on with our iron. Delicious, sticky, beautiful. I'll use my magnet to get this magnet out. Awesome. So what I'm going to bring around and show you is actually pure iron, okay, that we pulled out of that actual cereal. What it looked like before was it was just white and didn't have anything on the end. So what I'm going to bring around is iron that came out of the cereal because you're like, I'm not going to chew on a nail later, that much iron, but you do need iron in your diet. Okay, so I'm going to bring this around, see if you have any questions. You guys are working on the worksheet, and you're also doing your 3 lecture questions, okay? Awesome. All right, this is the iron that we pulled right out of that cereal. All right, so hopefully we're feeling good, doing some of the separation steps. So if you want, we can go over. We got a few minutes here. Here. All right, so the first one, separation based on boiling point differences, that was distillation. Separate techniques, difference, densities and solubilities, that was centrifuge. Yeah. Oh, they must have been higher, right? I think it would depend on what kind of food coloring they use. Does that make sense? If it was an alcohol base, it probably would have been pretty low. But I'm assuming it's a water base. But they make their food colorings with different types. So all I know is it must be over 100 degrees. Does that make sense? I don't know exactly what they use in that. Yeah. Oh, all we know is over 100 degrees Celsius, right? We can guarantee that. That's a good one. All right. So if you do differences based in solubility only, that's filtration. And then if you're doing differences in color, that's chromatography. So everybody feeling good with those? Distillation can only be done when you have a mixture with liquids and dissolved solids. That's like off to the side. Okay. Distillation can only be done when we have liquids and dissolved solids. Come here. Get. Oh my heavens, where's that little thing? Beautiful. Centrifuge does not work on dissolved solids. Okay, so the biggest thing about centrifuging, you cannot, cross this off really big. You cannot centrifuge out anything that is dissolved. You just can't. If it is dissolved, the only thing you can do is distill it. And filtration also does not work on dissolved solid. So you cannot filter or centrifuge if you have anything dissolved. Okay? Does that make sense? So then what you're going to do is they're going to give you mixtures. You're going to kind of go through and talk to me about how you would separate them. I want you to try these. And we can start with this again tomorrow. We can make sure that everybody understands. But I want you to try. If you had this type of mixture, how would you separate it? Okay? Thank you guys very much. Sorry for the back and forth, those of you at home. But I think I got all of your attendance. So I think we're good. Have a great day. Thank you, guys. Thank you. Thank you. We have a test on Thursday. So don't forget, test on Thursday.